Broadcast on?
My broadcast is on.
Because mine still says off air.
Mine says live. Interesting. And yours keeps flipping between my screen and your screen, so it should show.
There it is. No, it's
Oh,
live.
it showed? Okay.
Yep.
Just had a delay, probably. Alrighty then.
All right. So, have you taken the exam yet?
No, I haven't. I was planning on taking it tomorrow after I get as much homework as possible done.
Yeah, there you go. That's a good plan.
Yeah. You said you took it. Was it hard?
Oh, I mean, it wasn't bad as long as you understand what you're doing with the homework that we've been doing. You should be able to do fine. I mean, it tests you on everything that we basically learned. Like for me, I'm not very good with like the related rates problems and optimization and linearization. Like I'm not very good with those kind of problems. Like
Yeah.
I can sit here and I can practice them and I can look in examples and it makes sense, and then I get in the testing center and it all goes away.
Oh, I hear ya. I know. I sure I list like I know for all things that I know it's like optimization, related rates. What else?
Linearization.
Related rates. Oh, those stupid story problems.
Yeah.
Like those. That's like all the things that I was just terrible at. Was those four? Which it sounds like I'm not the only one there.
Not the only one.
Yeah. I'm trying to think if there's anything. I guess we could work on some of those problems if you'd like, or I know I didn't even get some of the story problems. Like there's the one we had earlier this week had like 10 story problems. I only got like 3 done and just like skipped it and like, oh, I'll deal with it later.
Right.
I don't know if you were the same way.
I think I did them all. But like the assignment that is for today, for Friday, it has a lot of those story problems, like for linearization and things like that. Hey, hold on just a second.
Yeah.
You got a phone charger?
Oh, yeah.
Sorry. I'm on my phone because I don't know if my computer's going to work, so I had to get on my phone again.
Yeah, no problem.
The battery decided that it wanted to turn down.
Gotcha.
I'm just getting plugged in here.
Okay.
All right, good to go.
Good.
So it looks like on today's problems, we're talking about like the derivative applications for exponential and logarithmic.
Yeah, the exponential / logarithmic derivative apps, is that the one you're looking at?
Yeah.
Yeah. Estimated salvage value and all this garbage. Yeah. Okay. Have you been able to get through any of it, or you still need to work through it?
No, I've done it. I checked it with the answer key, and it looks like all right except for one. But I went back and reworked it and figured out where I made a mistake. So I think for me, I got them all done. But if talk about a few of them or something like that.
Okay. I haven't done them actually yet. Yeah. I don't want to take too much of your time. Maybe you want to just like try one, just the first one to see what that one's like.
Yeah, we
At
can
least
do that.
Then. Sure. Okay. So let me think. Linearization, isn't that where you take the derivative of it and then you put in a certain value?
So linearization gives you like the point for, like in this case, it gives you the point 0, 1.
Yeah.
Y point, and then you find the derivative of the original equation to find the slope, and then you plug your x value in for the x of your slope. So like in this case, the derivative, what is the derivative of y equals e to the x?
It's going to be e to the x. Remember, right? E to the x is derivative is e to the x, right? Same with the integral.
Correct.
Well, integral you get plus c is the only difference.
Right. Right. So then in this case, you plug in 0 for e or for x. And so e to the 0 power is equal to what?
Anything to the 0 power is 1, isn't it?
Correct.
So
So then y prime basically your derivative is equal to 1.
gotcha. So the derivative d over x equals 1. Okay. So does that mean, is that the linearization at that number?
Okay. Now
Okay.
Let me look on here, just make sure I'm doing it right.
Oh, it's that line thing, isn't it?
Yeah, so now you have to do like the y minus y1 equals m times x minus x1, x sub 1. So like, so it'd be like y minus your y value, which is 1. So y minus 1 equals, and then your slope, which is what you found where that y prime equals 1. That's the slope.
Slope is 1.
Slope is 1. So you'd plug that in for m, and then you'd multiply that by x minus 0, which is your x value. Right?
Okay. Yeah, that's ringing a bell.
So that you distribute the 1, your slope, you distribute it over the x and the 0. So that just basically equals x.
Y equals x plus 1, basically.
Correct. That's your linearization. That's your equation.
Okay. And then we want to plug in 0.01 for x. Is that right?
Correct.
So y equals 0.01
Plus 1.
plus 1. So basically get 1.01. Right?
Yeah, is approximately equal to e to the 0.01. Because you're trying to find an approximation value
Right.
of e to the 0.01. So if you plug that 0.01 in for x in your linearization problem,
Right.
then that will give you the approximation number of e to the 0.01.
Right, because e to the 0.01 would be really close to 1, wouldn't it?
Yeah.
That makes sense. Now I'm thinking about it. E to the 0.01. Oh, come on. Got this new calculator. I'm still trying to figure it out.
Yeah.
Yeah. It's pretty fancy. I was surprised it even lets me do derivatives on it.
Oh, really? What kind of calculator is it?
It's an FX115 ES Plus. Just a little basic doohickey, but it's got a derivative button on it.
Oh, is it Casio brand?
Yeah, Casio.
Oh, cool.
Yeah, there's actually a lot. It actually does sums. It also does the NPR and NCR, if you remember that from Math 108. I always hated those, but anyway, it's actually got quite a few little things thrown in there.
I don't think I ever took Math 108.
Oh, good thing. I hated that class. It's probably why I hate these stupid programs here, but
Yeah. In high school, I took like calculus and I took statistics. But then I got back from my mission and I took Math 109, which is pre-calc.
gotcha.
And I took this class last semester. And now I'm taking it again to try to get a better grade.
Yeah, no, I hear ya. I'm trying to do.
So then I on to 215 and move on to bigger and better things, I guess.
Yeah, no. If you can skip Math 108, it's totally worth it. I mean, there's things that are helpful about it that you learn, but math-wise, there's nothing you're going to learn from it. It's more of a finance class than anything.
My wife took it last semester
Yeah.
and helped her out a little bit as well. I tried to help her out with it, and I didn't do very well at helping her out.
No, I hear you. I hated that one. I loved pre-calculus, but I had a good teacher for it. What was that teacher's name?
Johansson.
Brother Johansson. If you can take classes with him, best teacher I've ever seen.
Did you take campus or online?
On campus.
Okay.
So, I mean, for a campus one, he is excellent. I actually did take him for pre-calc and calc. I got a good grade with pre-calc with him, and calc I did okay, but by my own problems, I ended up having to retake the class. But great teacher, though, in spite of that.
That's kind of how I am. Like, I had Sister Harmon on campus last semester. She's super awesome. Like, she's the one that came up with the course outline for the online course for this class.
I swear I had her. I'm pretty sure I did, because this class feels like my last math teacher. I might have.
Yeah. Anyway, she's super awesome, but she taught it very well. She would help me understand it. It's just I'm very bad at taking tests. So even now, when I go to the testing center, like even though it's my second semester taking this class,
Yeah.
I draw blanks, and I'm like, I know how to do this, but why can't I remember
Oh,
it?
I'm so sorry. I've got the opposite problem. I don't have test stress at all. It's just I'm terrible with homework. Like it's like the first test I got like a 93, but I'm doing terrible at all the homework. I can not bomb. I can really do great in my tests, and my homework is terrible.
See, I'm the opposite. I do great on my homework, but I bomb the tests.
Oh yeah. I wish I could have both, but it seems like everyone gets one or the other. You either get test stress or you get homework stress. It's one or the other.
And it's not, I don't ever get in there and get stressed. I get like a testing block.
Yeah.
I can't remember anything.
Yeah, I hear ya. Gotcha. Okay. By the way, which one of these did you have trouble with? Do you want to hit that one?
I worked back through it and I got the right answer. Let me see. It was the number. I think it was number 4.
4? The Mediterranean fruit fly?
Yeah.
Okay. All right. Let's see. Would you like to go over that one?
Well, let's see. I went through and I got the right answer the second time.
Right.
That's where I made the mistake. I forgot to put a sign in the right spot.
Okay.
It was a stupid mistake, but it made it all not equal what it was supposed to equal in the end.
Happens all the time. Okay, then. That's fine. So I guess I just ask you a question that how do you actually get the jargon from what you're looking at? Because I always get trouble because there's just so much garbage in here. I don't even know what I'm looking at. Like when they give me a problem and say plug it in, I can do that. But when they're giving me there's some fruit fly. Okay, there's so many hours. They gave me an equation. I'm going to find the number of fruit flies. And well, okay, what do I do with that? What do you do to like break them down?
Okay. So, like in number 4, the first thing I did was I took the equation they gave us, the n of t.
Okay.
And I found the derivative.
How did you know to do that though?
I don't know.
That's like my problem. Well, like, is it a derivative? Is it an integral? You know what I mean?
That's kind of like what we do with all of these kind of problems is like even on number 1 when we started off with y equals e to the x when we found what y prime was. We found the derivative of it.
Right. At least that one they told us to find a linearization though, so then we know take the derivative.
Right.
You know?
I think most of these they're not like a linearization per se, but they're not like optimization. They're just a story problem that you got to find the answer to. But I know that on all of them, like the first thing you need to do is find the derivative.
Okay. Do you know how you can tell when you need that? Because like during the exam, did it say whether it was like a derivative section or an integral section or whatever for the story problems?
It didn't. I mean, like on the first section, it says, find the derivative,
Uh-huh.
and it gives you several problems to find the derivative of.
Okay.
And then it moves to like a story problem. It'll give you a story problem that I don't know. I can't remember for sure, but I think it had some kind of like a derivative application to it. It's like one of these. So you would use the derivative, and then you moved on to integrals, and then you had some different story problems with like related rates and optimization and linearization.
So you
I think there's 2 or 3 different ones like that.
okay. So most
And then no, you're good.
oh, so it sounds like most of the time you knew the story problem went to a certain one because it was always attached to the section.
Well, it just kind of like word this. I think like on the one that was about related rates, it said that this number is the rate of change at which water is flowing into a tank or something. It says what the rate, that this is a rate of change. So you could see how that would be like a related rates problem.
Okay.
And then like there was one that said that was like find like the maximum area that can be covered by so much fencing.
Which is probably an integral or
It's an optimization problem.
that's an optimization problem. I was thinking of the fact with you integrals, you can find the space between the two curves, and I'm thinking, okay, yeah, there's area there, right?
Right, and so you can do that, but it gives you like the total length of fencing you have, and then you'd have to find like basically the perimeter of it that uses the maximum amount of fencing but covers like the land area that's the right amount. It maximizes what you have and uses the best, or makes the best use of it basically.
Yeah. What do you use for that? Is that a derivative you're supposed to use for that one?
For an optimization?
Optimization?
Yeah.
I'm forgetting. Yeah.
Yeah, it's a derivative application.
Okay. Yeah, like I mentioned, like those are the ones I just completely been struggling with those ones, but okay. Okay, so back to my train and flute fly, I guess. So you basically took the derivative of that.
Took the derivative of that. So the derivative of 25 is 0.
0.
The derivative of negative 5 t ln of 0.04 t. So it's like first times the derivative of the second plus second times the derivative of the first.
Right, and then minus 1 at the end.
Minus 1 at the end, right.
Right.
And then take that, and I set it equal to 0.
Okay.
And then I solved for t.
What did you plug in for 0? You plug in y for 0?
For 0? I just set with the derivative.
Equal to that.
Set it equal to 0. And then you solve for t. So like when you get down there, you would subtract the number you get at the end. So like at the end right now, with the derivative, you have a negative 1. But when you get it all multiplied out and everything, you end up with like a negative 6 at the end. So then you would add the 6 over, then you divide by negative 5 at the first of the equation there. And so you'd have like a negative 6/5 on one side of the equals sign, and on the other side you'd have ln of 0.04 t.
Okay.
And to get rid of your natural log, you times both sides by e.
Okay. Yeah, that makes sense.
Because like e to the ln is 1,
E
right?
to the
So
ln of, oh yeah, e to the ln is 1.
ln, so like in this case, e to the ln of 0.04t.
Is 0.04t,
Correct.
right? Okay.
And you have that equals e to the negative 6/5, because you put your answer that you had on the other side in the exponent of e.
Okay, I think I'm following. Okay.
And then you divide by 0.04. And that would give you what t equals. And then you can plug it in your calculator, and it's like e to the negative 6/5 over 0.04, and it'll give you the number that it equals. And that's how you find the maximum number of.
Okay. Okay, I can definitely
Like,
try that.
here, this is an easy way to tell if this is like an optimization or problem. If it
Uh-huh.
says, like in number 4, the last sentence says find the maximum.
Okay.
So
Oh,
maximum is to maximize, minimize with minimum. Those are optimization problems.
right. If you're trying to find a maximum or minimum, you're trying to find an optimal position, right?
Right. Optimal size or an optimal number that works the best.
Right. So whenever you want a most or the highest or the least, that's always trying to optimize something. Okay.
Right.
Number 2, is that an optimization problem as well?
I
It
believe
does.
so. Yeah, so I found the derivative.
Right.
Well, first I moved the denominator into the numerator and made it to the -1 power.
Oh yeah, that always makes things a little easier. I agree.
Right. And then I found the derivative. And then with the derivative, I plugged in. It says how fast is the disease spreading after 4 days? So I plug in 4 for t
Right.
and solve, basically.
Okay. Um. Okay. I'm gonna sell blank cars. Great. Oh, and then 3 is a rate of change, right?
3 is the rate of change. Yes. So it's the thing you'd find the derivative of the original equation. And then it said x is in thousands of dollars. And so for x, you plug in 6 because it's only $6,000.
Right.
You plug 6 in and then solve.
Derivative 6 solve. Gotcha.
Yep.
But that one's gonna be a looking at it though. We know it's a rate of change because rate of change is mentioned, right?
Right.
Um.
So it basically says when you find out the answer, it's like that number is the number of cars per dollar spent on advertising. It's that rate of change. If they weren't advertising, if they weren't spending so much money on advertising, they wouldn't be selling as many cars. It's
Right.
change. If they spend more money advertising, they'll sell more cars.
Okay. Okay. I guess that makes sense. Okay. So whenever you see rate, you know it's gonna be rate of change. So 5's rate of change then, and 7's rate of change.
See, the only thing on the rate of change problems
Yeah.
is that once you find the derivative, you're plugging in numbers
Mm-hmm.
for the variable.
Okay.
Like on the optimization problem
Okay.
for number 4, you were solving for the variable. You were finding the number of that variable, not plugging in a number for that variable. Does that make sense?
To be honest, no. I'm just nodding my head.
Okay. So like on number 4, we
Okay.
went on the derivative, and then we solved for t. We found what the variable was.
Right. We try to find what t equaled something after we set the derivative, or we set y prime.
Yeah, you said
Y prime equal to 0,
with a 0. You
and
said
we look for t. So for an optimization, that's what we do. Versus a rate of change, we plug in a number to find out.
the derivative. See, like in number 5,
Yeah.
you find the derivative of s of t,
Mm-hmm.
and then it wants to know what the rate of depreciation is after 1 year,
Right.
after 5 years, and after 10 years.
We plug in that number for the x for A, B, and C, basically.
Right. Well, no, you plug that in for t, and you just do basically three different problems there.
Yeah.
Like s prime of t is equal to, and plug t in for where, or sorry, s prime of 1, you plug 1 in where t is in the derivative.
Right. Right. And you do the same for 5 and 10.
Yep.
Gotcha.
And give you the value of depreciation.
Okay. Okay. That makes sense.
The same thing.
Sorry.
So it's like the same thing in 6.
Okay, I'm looking
You
at it.
find the derivative of at.
Okay.
You plug in
1, 5.
1 and 5.
Yeah, at least 6 is nice because it just gives me, hey, find derivative of a relative to t, and find derivative of a with 1 and 5, and interpret the results. That's the fun part, though. Then they say, okay, what actually does that mean? Okay.
So basically is like find a prime of t and a
Mm-hmm.
prime of 1 and a 5.
Mm-hmm.
That's basically saying a prime of t is your original derivative problem. And then a prime of 1 is like after 1 hour, bacteria is growing per hour.
Right.
And after 5 hours, this is how much bacteria is grown per hour.
Right.
So
It's going to be the Good.
So like basically to like interpret that, you could just say that, after 1 hour, the bacteria is growing at this many bacterium per hour. And then after 5 hours, it's growing at this many bacteria per hour. That's how you would interpret it.
Right.
You just put into words the answer that you found.
Okay, that makes sense. That makes sense. Okay. Okay.
It's like you watch those like TV shows where like someone smart's really carrying on,
Okay.
and like, okay, now say that in language that I'm going to understand. Speaking all this language, and then we need to put it in some kind of language that someone who doesn't speak the same language as us mathematically, they're going to understand that.
Yeah, I hear ya. It's dumb it down. Keep it simple.
Right.
Yeah, I hear ya. I actually hate these problems a lot of times because I'm like, they give us this nice little word problem, but I don't know. I wish they did it differently. But no, I understand that totally. Because I'll often explain something at a more complex way, and then someone's like, okay, so what does that actually mean? I'm like, okay, well, it means this. Anywho, okay. All right, I think that's helping a little bit because I think it's my big problem with these story problems. I just don't get what they want me to do with it. It's like, okay, you gave me this problem. Now, what do you expect me to do with it? And because I mean, I could integrate these numbers. I could I could do all kinds of stuff to these numbers.
No, I think that this thing that I think I forget it often is that with linearization, optimization, rate of change, related rates, they're derivative applications. So they're specific to a derivative, not an integral.
Right.
learned the integral applications yet. I'm sure we'll learn that next week.
I'm sure we will.
Because that's just like the stepping stones. You learn about derivatives, and you learn about derivative applications, and you learn about integrals, and you learn about integral applications. So
right.
The application specific to derivatives. So we know that with any kind of problem like this, we're going to be using a specific derivative. We're going to have to find the derivative at some point.
I guess that's true. I guess what I'm wondering is, like, eventually you're going to run into real world problems. It's like, I'm going to run into a real world problem. And it's going to be one of these 50 different story problems throughout the whole calculus class. And how am I going to know which one it is, Where it's like, I had a flat tire and I wanted to find out how much time I had before it was empty. It's like, I guess I could use a related rate, I think, or something like that. No, you could use one of them. I know you could. I don't remember. But I know you could do it.
Yeah, it's that whole math in the real world that gets me. I could care less. It's like, okay, I know my tire is going flat. When it goes flat, I will stop and figure something else out then. But
yeah,
until it's flat, I'm going to keep driving.
No, I hear you. I really do. Because a lot of those problems, like, it doesn't really matter. I don't care how long the tires got, but I just need to get to somewhere I'm going, because I sit here calculating it. It's not going to do me any good.
Right, you're wasting time calculating it when you could be driving, making up time there.
Yeah, pretty much.
One of those.
But yeah, only time that would help is, like, maybe it's like, how long does my donut have, and which shop can I get to?
Right.
Because, like, they're only, like, meant for, like, I think it's like 150 miles or something. They have a really low limit. You're not supposed to really drive on them at all. I found out because I've had to change my tire recently.
Yes.
I've been paying for a lot of those lately.
They're not cheap either.
No, they're not. I just spent money I didn't have on them. But hey, the car drives better. They had 0 out of 36 tread, and I was told you're not allowed to do that. They're kind of smooth. I thought it was good to have smooth tires, but oh well. The back ones had something, so.
My tires are kind of looking like that right now too.
Yeah. I just trying to find the Walmart guy. I'm like, oh yeah, they're bald, and he comes out with this little thing to try to measure it. I'm like, there's nothing to measure. The whole thing is smoothed over. He's like, oh, these really are flat. I'm like, I told you they're bald. You're trying to get your little meter. There's nothing to check. It's flat.
Right.
So I don't know. I just had to laugh at the fact that he actually even tried when I'd already told him that they're just flat. But oh well.
Yeah.
Real world problems, right? But anyway, is there anything that you struggle with, though, that I could be able to help you with? Like, are you doing good with integrals? Do you like them?
Yeah, integrals and derivatives, they really make sense to me.
Yeah.
These story problems that we're talking about here, but like, I can sit here and explain it to you and it makes sense to me and everything's good. And then I get in the testing center and I draw a blank and I'm like, now I know how to do this. And I find the derivative and then I get stuck and I can't remember what I'm doing.
I know. I hear you. That can happen. I hate it when I'm like all the way, like halfway through a problem and I'm like, oh crud, what was I doing here? I was doing something and then I was doing something else. I skip steps. I think that gets you in trouble too. You're going from step like 1 to like 5 because you don't want to do all the intermediate steps.
Right.
So, but anywho,
okay. Good. I just need to practice more on these kind of stuff.
Yeah, I mostly just needed help with trying to figure out story problems, like, what to do with them. I've been practicing linearization, related rates, and optimization a little bit. I'm going to try to do my best before the exam. Hopefully I do okay in them. You said they were tough, and I'm hoping I do better. Not to be mean, but I really want to do good.
Well, they were tough for me because I couldn't remember how to do them.
Oh, I'm sorry, man. That sucks. That really sucks.
If you can practice them and understand how to do them and remember it when you get in there, you'll be fine.
Yeah, that's the key, though. I need to learn them now, otherwise I won't know them then.
Right.
I just struggle with getting it the first time, and once I got it the first, second, and third time, tests don't matter for me. But oh well, we're all different. Anyway, I guess I'll probably let you go though. You probably have a long night too. America, I guess have a good weekend.
All right. Sounds good. And we'll just let me know if you need any help during the week or anything like that. Otherwise, we'll just talk next Friday.
Sounds good. I appreciate it.
All right. Hey, send me the link to the video.
Will do. Will do.
I guess you'll have to teach me how to do this next time because I guess I will be the group leader next week.
Well, there's only 2 of us, so.
We'll be switching back and forth.
I know, right? We should find the other guy, though. I feel bad he's not in it even.
I feel like he might have dropped the class.
I think that they had like half the class drop, to be honest. Because I swear there was more numbers than there are now. But
yeah.
I'm not surprised. But okay. I'll have to find out from my wife, and I'll tell you later once I know how to do it myself.
All right. Sounds good.
Okay.
Okay. We'll talk to you later.
See ya.
Bye.